Creating fabs for steel bars. In this video, we will describe what is necessary to do in order to create a fab for the steel bars. We will include all the information that you need to draw into your fabs. And finally, we are going to be talking about the special naming convention that you require when you are creating steel bars. We use a special naming convention, call it for the steel bar, when we use the length and the thickness of the bar. For example, in the picture below, you can see in a steel bar, it's 1 1/4 by 4 1/2. So we use the prefix STL, and the part it will be named STL 114412. Sometimes, if you have the same part but with different holes layout, use different fabs numbers to make a difference. For example, in fab number 1, the holes are 1 9/16 from the edge. But in fab number 2, the holes it's 1 16 from the edge. Even when we have the same thickness and width of the bar, it is important to make a difference between those two conditions. As you can see in the image below, we have 1 9/16 and 1 9/16 then on the other side. Make sure, like you previously been looking into or the other videos about how to create break-shaped fabs, but essentially we're going to be using the same command, W-block command. So any part can be easily modeled and extruded into a 3D part by drawing into the fab or the dies folder. Remember to save the die in the same location, project folder, takeoff, fab, and dies. Let's see an example on how to do this. If you go to your exercise on detail 500, you notice you have a steel bar reinforcing. The bar is called 3 1/4 by 2 3/4, and it's called by 10 feet long. That means like we need to draw this in our detail. So let's open that detail and create a layout for our steel bar. Once that we are there, remember, like we can select the entire part because we need only the single shape of the steel bar. So to do that, we can draw a rectangle here and draw the shape of the steel bar, then move it and rotate the part so we can collect the die for the steel. Remember to use the command W-block command. So once that I have it, I select the object and then I save it into the dies folder under the project, drafting, takeoff, fab, and dies. And I'm gonna name it the same as we previously discussed. In this case, STL 234, because it's 2 3/4 width, and the thickness is 3/4. So I hit save and okay. Now it is important to create the tag and then use the QB command in order to create a 3D model. For reference, you could see our previous video about how to add tags to your elevations. Once that you QB in command, you can start creating the fabs and adding all the dimension and information required in this steel reinforcing. Let's go back to our elevations. Remember, we are using the location from tags, takeoff. We'll go back to drafting, drawings, fill use tags. We're going to use the same elevation from our exercise. And I type M2 in order to see where are my steel reinforcing. So in my PDF, I go to the elevation, I will notice like I have the reinforcing on these conditions only at the gems, left and right, which is the same steel reinforcing. So basically what I need to do is tag the line here in order to create that steel reinforcing. I need to open my UD windows. And I need to open my database from that project. And once that I have the right database, I can refresh and I can see now all my parts. In your exercise, make sure to use the correct database in order to get confusion or different mark numbers. So this time I'm gonna call the steel STL under the same prefix for BSXX. I can call it the description, but I need to add it's a vertical part. So as I previously called it, this is an STL 2 3/4 and 3/4. Just make sure like I'm right. 2 3/4 and 3/4 is correct. So in this case, the finish is gonna be red oxide. And the length needs to be 10 inches feet, which is 120 inches. There you go. So make sure like have the right information, STL23434, red oxide, capital here, red oxide, fix, perfect. And finally, I need to add the fastener. In this case, it's the 62 CP. And I have 3 in total in this part or in this steel bar. There you go. Hit apply, and there you go. Very good. So now I go back to my elevation and I start tagging as previously mentioned or discussed. Remember to go here to the metal tag and use the right STL code. And I can draw a line from 120 inches, which is 10 feet. There you go. Remember that if you can see the takeoff property, it's important to use takeoff properties to open that box here. So now that I have selected that one, I can add my details as BSXXX. And again, I'm using the same elevation, BS01, and distribution is always 1. And this time I'm gonna change this to magenta. And I copy this from here to here. Now I need to UPD my elevation. And as we previously discussed, a new box is coming. In this case, it's asking me for MM, and I say no, because I want to use the prefix STL for the steel. So this is going to be happening every time I have a new part that is not a prefix. And again, it's asking me, it's not in a standard. Do you want to use it? Yes, just make sure. Perfect. So again, giving a little bit of practice what we did it previously, you're going to see your text appear on the tag number 4 or LMM. So it's important to just adjust your text and remember to change it to the layer number 5, which is LMM2. So if I type LMM2 on the command, I'll notice I have my text there, and now I have the previous that I was working on it. Now it's important. Now let's gonna use the command that we already described, the QB command. So if you click QB here, this tag, and it's gonna generate my steel bar. So I can make sure, or I can double check how it looks like my fab if I go here and right click and click an Open Fab template and see the logic on my fab, which is good. Looks good to me. And I need to start creating the fabs. What do I need to include into my fabs? Well, information needed in your fabs. For example, we're gonna need complete dimensions, the cut size, the thickness and material, the notches and holes, placing dimensions from the edge. We're gonna need the diameter of the hard hole, and we can use the Walters and Wolff standard shop drill and punch size fasteners. In case we are using a countersink hole, then we need to include the direction of that countersink drill with an arrow. and we need to include the fastener description and type. So let's gonna see an example how your steel bar looks like. As you can see, we are using the X title border 4B. We are using two viewports that I'm going to show you in a moment how to create these viewports. And keep in mind, like when we are doing this, we want to use the same X title border here and X title border 4B down here, but we want to include the steel grade node. And let's gonna start doing one by one and see how do you do it. So let's gonna start, how do you add the X title border 4B? Okay, so going back to my fab, I can go here and just turn off the border 1 and turn on the border 4B and the 4. So now I have the right view that I was looking for. Now let's gonna talk about the views on the viewports. Well, to activate the viewport, use the command BP and then later MB. That's gonna provide us different views from the same. The rule that we are gonna be following is DLO side match with the view from the detail. In this case, on the bottom picture, we want to use the DLO side on the left to match. What does mean that? Like if I go back to my detail on PDF and I click here, I want my fab looks like this from that picture. So the bottom picture is going to be matching with this perspective or view from the bottom. Let's go to CAD and see how do we do that. As we previously mentioned it, we use the command BP and then the viewports are open. Now I want to use MB and it's going to ask me which one I want to use. So as you can see, I can on or off or do another, but I want to on, and it's asking me what views you want to on, and I click those at the bottom, and there you go. So once that I have that one, I can close the viewports, just type in BP again, and that will remove the entire part. What else do you need in your fab? Let's gonna talk about the dimensions. All the dimension needs to be on the left side. As you can see, if we have a counter board, we need to draw those dimensions, but always at the top and the left side. So I'm gonna go back to my fab here and do the same logic. So in this case, I have an overall dimension there. And from here to here, 2 3/4. Keep in mind, like the first view we're having is the overall dimension. The second view, we want to provide the direction of the hole and the location for that one. So before I move to create that one, I want to create the hole, the notches. So let's gonna do a notch, but go back to our detail. My hole, it's centered 1 3/8 and 1 3/8 from edge, which is center. And it's called at 62 CP. If I want to verify what's that diameter, I can go to the notes and check the diameter for the 62 CP. It's at 3/8. If it's a hard hole, I can use the table listed under the WW takeoff. You can do it the following way. You can go to the takeoff and go to standard. And in a standard, it's gonna make you open this wiki page and you click on fabrication standard and scroll down and you will find that table. If it's a 3/8 bolt, then I need to use a 7/16 diameter hole. But keep in mind, like this is a different condition because it's not a hard hole. We are using a tap and drill hole. So if I go back to the detail again, 500, you can notice like it's tapped steel for attachment. So in this case, the hole needs to be a little bit smaller from 3/8 to match what I want to do. In that case, I need to use a different table, and that table, you can find it on the following location. If you open a new window and go to M, drafting, and S Garcia, and we use this one here, drill chart. So this drill chart, it's for tap and drill. What I need to do is I need to find the diameter that I was looking, and the number of threads that I have. In this case is 60 CP. I need to go back to see how many we have. So it's at 3862 CP. It's 38/16 and 2 inches long. So 16, it's my key here. So you can see, I need to create that hole for 3/8. If I'm in aluminum, then I use this one. If I'm in stainless steel, I use this one. So in this case, I need to use a Q hole, or 3.3320, which is the diameter that I need to draw. Okay, with that in mind, so I go back to my fab here, and I'm gonna create that hole on the center. How do we do that? Okay, so I can go to the model space, and using a simple circle with that diameter 0.3320. There you go. And I use extrude command to extrude that one. So now the only what I need to do is place it in the right position. So if I go here to the wireframe, I can use the arrows, and it's just more accurate. So I go here to the center. I know it's in the center, and I center there. So now I have it on the right position on X and Y, and I use C and just center it on that particular dimension. There you go. There you go. Okay. So now what I need to do, it's going back to my detail just to make sure where is that place. So it's from detail 500. So it's a 3 total, 6 inches from each end and center. If that's the case, I need to move this hole 6 inches from the end, and I have the right location for my hole. So if I hit notch and select the extrusion to notch, and then the second click, it's what I'm notching and asking me what I want to do. And there you go. I have my notch there. I can copy this notch to the other side. It's very simple. It's just only mirror copy and paste that copy, and it appear in the same location, 6 inches from the end. And finally, the only what I need to do is insert that notch again and just move it to the center in order to have my 3 holes located on the right position. There you go. So again, I do my notch here, main extrusion, and what I want to extrude. And there you go. I have my 3 holes there. So as you can see here, I have my reference there. Now I need to draw the dimensions, but I need to add the hatch. And there is a specific command in AutoCAD. It's called face hatch, or hatch face, I'm sorry. Hatch faces, yeah, that's the one, hatch faces. And the only one I need to select, it's the faces that I was thinking to hatch. In this case, is this inside of this steel bar. It's a solid face, and I hit enter. I know I double check it's correct what I'm selecting. Hit enter, and there you go. See, I have my selected steel bar. So now it's only matter to draw the center line for that specific fastener. I changed to the correct layer center line. If I go here and then center it, and then I copied that one. I can copy that one to here and copy there. There you go. So in this case, I don't have counter bore hole, so I can recycle this dimension. It's exactly the same because it's passed through. But I have a center line, which is good to me to have the center line because that's what I'm going to use as a reference. Center line there. And I use this line to use the same direction. And again, 138, and I use that one direction to center it, and I have my dimension. I need to add now the instruction, but let's go back to our Fab standard. The dimensions for my holes needs to be following the same logic. You need to include the direction of the edges and the midpoint only at center. So let's gonna imitate that one into our Fab. But before we do that, I'm gonna copy the center lines and move it into my little part here. If I use CR command, CR, it's gonna copy and then rotate later at the same time. So I'm saving time there. So I copy here and I just placed it into the center. So the only one I need to do is just copy this one here in each single center hole in order to have a reference line. And there you go. There you go. And finally here. So following the previous logic, I need to add the dimension from here to here, 6 inches, and the same story here from here to here, 6 inches, and the midpoint, which is called from here to here. And I need to fake this dimension in order to put mid. There you go. So I have now all my dimensions. What else do I need to include? I need to use then the final or the use for the steel grade. And before to do that, I need to include the hole diameter and all the instruction for the hole. So let's go back to our Fab and include that hole. It's as simple as creating a letter or liter and click here. And I'm going to include the diameter. In this case, it's 0.03320 diameter, hole 16, and tap and drill. So I can change the instruction a little bit here to show the instruction first and then later the diameter. There you go. And I need to include the quantity of this tip 3 times, tap and drill these diameters. And that's it. That's all what I need on my hole diameter for this example. Sometimes we can add the whole description. In this case, we are going to add it, and I'll show you how to do it. If you go back here, we can add the fastener type on the brackets. 62 CP needs to be the same logic that you find on the notes. And we're going to use the command insert descriptions, enter. And if I click on this and hit enter, automatically it will give me this. So I add the note 4, and there you go. Match and bold. I have the description of the bolt that I'm using and the tap and drill direction. I can make a little bit of adjustment here, maybe that one. That's good. Looks better. Now I have that information ready. So now that I have that one, I have completed my Fab. How do you add the node? Well, we are not going to see the use here because that is directly into your database. So you need to go to your database, hit F11, and we are going to look for die custom. It's a table, call it die. Don't get confused because it's different die tables here, but we are going to want to use that one. Oh, no. Oh, yeah, that one, die info. Perfect. So here, the description is where you are going to add your, let me double check that one. Wait a minute. No, that's good. Yeah. So yeah, don't get confused. We are using die info. Die info custom is this one here, die info. So here, description is when we are adding or a steel bar. What do we need? We're looking for. Basically, we want to include into the description the description of the thickness and the width of the steel bar and the steel grade node. That information, it's on the shop drawings, and you can see if we go back to the shop drawings into the instructions for the project notes, you notice like when it's called for steel, area, fastener store. Well, concrete, I don't see on this project. Well, maybe they forget to include that condition, but you will notice like you have it here, what steel we're using. For this example, we are gonna create steel or the description of the same steel bar. So let's gonna look at it. Let's gonna say we have, going back to AutoCAD, I'm sorry, to the database. There you go, and this one. So I wanna call it that one, steel 3/4 and 2 3/4 STL bar, and under parentheses, ASTM A36. And there you go. So that's the description of the part, and it's going to be linked to this part number. So that's important to have it. There you go. So once that I have all that indications on my Fabs, I'm good to go and continue. So as we already explained it, it's time to you to let's get started. So now it's your time to continue with the exercise. This concludes our video.